Oh, I'm stuck. What is up, my fellow viewers? I hope your day is going well, and with this new episode, maybe even better. We will continue on the same path from the last episode where we added a hitbox for the player. Today we will add gravity to our game, and with that, also jumping. Now let's just quickly go over what we did the last episode so we are up to speed. Last episode, we added the groundwork for all our collision detection. We went over quickly what we were trying to do, which is stopping the player from overlapping any level tiles, giving us the ability to detect the level. First, we made a method that will be used to check for the collision itself. Once that was coded, we tried it with the size of the sprite image and then the smaller hitbox. And our hitbox is just the approximate size of the player. The important thing is to make sure that the feet of the player does not have any space to the bottom. Because if there is any space between the feet and the bottom of the hitbox, that would make us run above the ground, which is not something we want. We want to be able to run on the ground, not above the ground. And I think that sums up the last episode well enough for us to start this one. Let's go. Alright, let's begin by adding a few variables that we're going to need for this episode. First, we're going to need a boolean, just like left, up, right and down. And we are adding a boolean for our jump so that we can just hold down our spacebar and the player will continue to jump as long as we are holding it down. And the second variable will be a private float air speed. And this will simply store the speed which we are traveling through the air. Either by we're going up, we're jumping, or we're going down, we're falling. So we're just gonna call it airspeed. And the next one will be the gravity. Private float gravity. And gravity here will be a constant that we can play around with depending on how fast we want the player to fall back down. The lower value we give to gravity, the higher the player will be able to jump. So we're just going to give it some random value here. I think 0.4 float is good. And we're also going to multiply it with our scale. The next will be the very value we apply to our airspeed when we are jumping. So as soon as we click jump, we want to go straight up. So we're going to call it jump speed is equal to a negative, because we're going up in the y direction. So we want to set it to 2.25 float maybe, times game.scale. And the next one is going to be a private float as well, and it's going to be called fall speed after collision. And this is just something that I like to have in case the player are hitting the roof. So in case we are hitting the roof, we're setting a new value to the airspeed. And I'm going to say 0.5 float times, well, game.scale. And the last one will be a private boolean called inAir, and we're going to call it false by default. So all of these will be for jumping / gravity. So we can keep track on what they are. And next we will go down to our UpdatePosChange method. And we're going to change a lot of things in here. First of all, we can keep moving equals false, but we're only going to check left and right. Up and down will no longer exist because now we're going to have gravity. So we're just going to remove that, but we're going to check for if we are not in the air. Meaning if we're not pressing left or right and we're also not in the air, we're standing still. So let's get out of here. And next up, we're going to remove Y speed because we have this airspeed now, and we need to store airspeed up here because we're going to keep track of it for every update. If we are falling, then we're falling with one speed the first frame, the next frame we're going to fall a little faster, the next one a little faster, and so on. So that's why we're going to have to store it up here, and it's not going to be Y speed, it's going to be airspeed. And we're gonna clean this one up. It actually doesn't matter if we're holding down right or not, if we're holding down left or not. And we're also going to say x speed minus equal player speed and then plus equal player speed. And we're gonna change this into just a normal if statement. So both of these could be true, and if both of them are true, well, x speed is going to be 0 anyways, because first we remove player speed and then we add player speed. So this just looks a little bit cleaner in my opinion, First of all, let's just remove this comment from like 2 episodes ago. And we can actually remove up and down check because we're not dealing with that anymore. And we can actually comment this one out for now. And then just get some room here. Because here is where we're going to change the most. First, we're going to check whether or not we are in air. So in air. If we are, then we're going to have to check both X direction and Y direction for collisions. But if we are not, then we only need to check in the X direction. So that's much easier. So we're going to start with the X direction check. And we're actually going to make a update XPOS method, which will take in the X speed. And that's all we need to call in there. So let's just create this method. And this method will be very similar to what we had up here. Let's just copy this like so. And let's uncomment. But we don't care about Y position, and we can remove moving. And we don't need Y speed there either. And if we can move to that position we're trying to move, great, then just do it and we're done. But if we cannot move to that position, meaning that we are colliding with something, there is still space between the player and the wall, because right now we're only able to collide with a wall. So there's some space between the player and the collision, which is in this case a wall. So we want to move next to it. We want to move so that our hitbox is hitting the wall, so they are next to each other. And we're going to do that by saying hitbox.x is equal to, and here we're actually going to add a new helper method that's going to take in the hitbox and the X speed. So we're going to call it something like get entity XPOS next to wall. It could be called something more fancy, but now we know exactly what it does. And then we give it the hitbox and also X speed. And let's just copy that so we have the same name. And into our helper class here. And we're going to add a public static float get entity X position next to wall. It took in the hitbox, which was a rectangle 2D.float hitbox and also float X speed, right? Yeah, that looks right. And in other circumstances, we would have needed the level data array as well, because we need to know where we are, what tiles are we colliding with, or what's the tiles next to us. But not in our case, and that's because our hitbox is always going to be smaller than a tile. Not just in width, but also in height. And that helps us a lot. Because now we know that we are colliding either to the left or to the right. We don't know the direction yet, we haven't checked for it. But we know we're colliding either one tile to the left or one tile to the right. So first we're going to check whether or not it's to the left or to the right by if X speed is more than 0. Now we know that it's to the right. Otherwise it's going to be to the left. And X speed cannot be 0 here, because if X speed was 0, then we would have no collision. So we know that X speed cannot be 0 here. It can only be more than 0 or less than 0. Before we start coding in any of these two brackets, we need to calculate what current tile we are on in the X position. So we're going to add a int current tile is equal to, and we're going to recast it to int because it's going to be float values. So hitbox.x divided by game.tile size. And now we get the current tile our player is on. And it's going to be either colliding with the tile to the left, which will be 1 less, or a tile to the right, which is +1. And if we're colliding towards the right, that means that the player plus width is hitting something on the right. First we will need the int tile x position, meaning we have the coordinate, which might be 11 or 12, but we need the position in pixels, which will be equal to current tile times game.tile size. And now we have the actual pixel value for the current tile. And for us to place our player next to the tile on the right, we need to know the offset between the size of the player and the size of the tile. So we need a int x offset is equal to, and we need a int recast because we're going to get the width, and that's a float. So game.tilesize, we need to start with that, minus hitbox.width. So we know the difference between the size of the tile and the size of the player, which will be something we don't know just yet, but we're going to need this x offset. So all we need to do now is to take the current position of the tile plus offset, and if we do that and return it and give it to the player, then the right side of the hitbox will now be right next to the wall on the right. So return tile xpos plus x offset, but we need to go -1. And this -1 is because the very edge of our hitbox is actually going to be inside the next tile. So we need to go back 1. And if we're colliding with something on the left, which is much easier to do, all we have to do is to return current tile times game.tilesize. Not tiles, with tile size. That's all we need to do for the left side. And we can save that. And now we can go back to our player class, and this one needs to be imported. So up here we add, we can actually remove this and add a star, because I know there's going to be more methods inside the help methods class. So we might as well just import all of them at the same time. So now we are placing our player next to the wall. So we might be able to try this now, hopefully. Let's give it a try and see what happens. So just like normal, we have our player here, animations is working, and if I run to right, there's no animation because we removed it, but I am hitting the wall and the hitbox is not inside the next tile, and to the left, it's the same, we're not next to it, which is much better than before. Now it's going to get a little bit more trickier, because when we are in air, not only are we checking up and down, we're also checking left and right, because we could move to the left or to the right while we are in the air. So we need to do several checks here. The way we checked before we started with this episode was that we checked both the X speed and the Y speed at the same time. But what we are going to do now, in order to make it a lot easier for us, first we're going to check up or down, and then we're going to check sideways. So first, inside our inAir bracket here, we're going to check if can move here, just like before. But we're only going to check the up and down, so hitbox.x, and then for y, we go hitbox.y plus airspeed. And we're going to assign a value to airspeed in a second, but first we're just going to check here. And then we're going to add hitbox.width and hitbox.height level data. And in this bracket, we are able to move wherever we're trying to move up or down. So we're going to say hitbox.y plus equals airspeed. Then of course we need to increase airspeed plus equals gravity. And if it is a negative number, it's going to slow down because we're going up. And if we're going down, it's going to increase our speed. So that's what we need to do. And as we could move into this position, up or down, we're also going to do UpdatePos. And our UpdateX position method is already checking if we can move left or right. If we can't, then we move next to it. So we don't have to type this one out again. That's why we have a specific method for this. So all we have to do is call this method and it will take care of the left and right. But what happens if we cannot move up or down? Meaning that we are either hitting the roof or we're hitting the floor. So we need something similar to this inside here, that we get the position next to the wall, but in this case we need the position either next to the roof or right under the roof or right above the floor. So hitbox.y is equal to, let's call it something very simple so we know exactly what it's doing. Get entity, because the player is using this as well as maybe an enemy. So get entity y pos under roof or above floor. It's not the shortest, but it tells you exactly what it's doing. So hitbox and also airspeed. And let's copy this one and go into our helper method here again. And right there. So public static float. We need the same inputs, except it's going to be a y speed and not a x speed, actually airspeed. So we know. And this method is going to be very similar to this one, but instead of x, it's going to be y. So first we're going to need this get current tile we are on, because we know it's going to be either right above us or right below us. And as our hitbox is smaller than any tiles, it can only be one tile up or one tile down. So we can start by doing that. Then of course we're going to need whether or not we're going up or if we're going down. So if airspeed is more than 0, that means we are going down, falling. We're gonna call it falling, else we're gonna call it jumping. And I actually like to have a little space there, like so. And just like x position, we need a int tile y position. We had a tile x position, now we need a tile y position is equal to, we can actually copy this, like so. And just like the x offset, we're going to need a y offset. So y offset is equal to, you know what, we can actually copy this entire line instead of typing it all out. But instead of hitbox width, it's going to be hitbox height. Height, like so. And we're going to return tile y pos plus y offset. Oh, it's not x offset, it's y offset. Mine plus y offset and -1. Just like we have up here, if we don't add -1, we might be inside the tile, so we need the -1. And for jump, actually we're gonna call falling, touching floor. And for jumping, it's pretty much the same. It's actually exactly the same. So return, like so. They are very similar, but we're using airspeed instead of x speed, and it's width and height is the difference. So now we have a method that's going to place us right above the floor. So 1 pixel above the floor will be the bottom of our hitbox. So our hitbox is touching the floor. And if we're jumping, we're going to hit our top of our hitbox into the roof, which is exactly what we want. Before we check the update x position method inside here, we need to check whether or not we hit the floor. Because if we hit the floor, then we want to reset inAir, for example. So we're just going to check if airspeed is more than 0, meaning we're going down and we hit something. That way we know that we hit the floor. And if we did that, then we say reset inAir. And that's going to be a method. Let's create it. And this method is going to say inAir equals false and airspeed is equal to 0, like so. But if we did not hit the floor, we hit the roof. And then we want to add a else and say airspeed is equal to collision, or rather fall speed after collision, the one we had at the top. Of course, we could set airspeed to 0, but I like to have it at a little bit more than 0. It feels a little bit better. And after we've done all of that, we just say update x position with x speed. Everything with our checks right now is complete. We just need to, we can actually remove this. And at the very bottom, we can remove this bracket too. And at the very end of this method, then we say moving is equal to true. because if we weren't going left or right or in air, then moving is going to be false and we leave the method right here. But if we do get in here somewhere, we know that the player is moving, so we put moving at the bottom. Therefore, we don't have to put moving in every bracket here. We know that we're going to get to the bottom here in case we are moving somewhere. So moving at the bottom, and that's all we need to do for our moving boolean. We are almost done in this method, but we need to add a check, just like the left and right. In case we are jumping, we need to set inAir to true somewhere, somehow, when we are pressing, in this case, the spacebar. So right underneath our moving equals false, we say if jump, because we have a boolean that says jump. If that boolean is true, then we say jump. And we're going to add a method that is jump. And this method is going to first check if we are in air. If we are in air, then we're not going to jump again. So then we just return. However, if we're not in the air, we want to say in air equals true. And air speed is equal to, I think it was jump speed, right? Yeah, jump speed. So we get a initial speed of negative 2.25 float times scale. So whenever we click jump, we get airspeed to our jump speed, and it's going to increase over time here, as long as we can move up or down. If we can't, then we're going to get a new position, and if it's on the floor, then we reset it. Otherwise, we set airspeed to the speed after a collision. And that's pretty much it for our update position. But before we can even test this, we need to go to our keyboard inputs and add a few lines. Inside our key released, we're gonna check whether or not it's case key event dot space. If it is space, meaning spacebar, we can actually copy this, goes faster, or rather, we can copy the entire thing. Then we say not set right, we say set jump to true. And I just realized we don't have set jump yet, so back to player class. At the very bottom, we say public void set jump boolean jump, and then this dot jump equals jump, like so. Yeah, and that should go away. Perfect. And in case we are not actually true, it should be false. My bad. Now we can copy this, go to our key pressed, and say true. So here should it be true. So I think it's time for us to try it. So let's run it and see what we have. I can move next to the wall. So let's see what happens when I press spacebar. I fell and I hit the floor. Perfect. I can jump. Sweet. There is one more thing we need to do for our collision detection, and that is if I just run here, I'm now running on inside the air, which is not what we want. And that's because we don't check whether or not I am on the floor after each move. So right here I am on the floor, here I'm not on the floor. So we need some way of checking whether or not I am on the floor after each successful move when it comes to only X direction. So back to our player class and back to our update position method right here. And inside here, right underneath our if left and if right, we're gonna add a if not in air, meaning we're just running left or right. And in here, we're gonna check whether or not we are on the floor, but we're gonna check if we are not on the floor. So if not is entity on floor, and hitbox, and of course, level data. If we are not on the floor, then we want to say inAir equals true. And then, of course, we're going to enter inside here. Now we need to go to our helper methods and create the last method we need in here, which will be a public static boolean is entity of floor, and it was a hitbox we took and also a level data input, like so. And then of course brackets. And inside here we just want to check two positions. We want to check check the pixel below bottom left and bottom right corners. And if both of those are not solid, then we are in the air. First, we're going to check if the bottom left is solid, or rather not is solid. And we already have this method here that we can use. So if not solid, and we're going to pass in hitbox.x and hitbox.y plus hitbox.height bottom left, then hitbox.width right. No, level data. We don't need that. So if this one is not solid, then we need to check the other one. Then we go if is not is solid, just like the other one. We're gonna copy this. And we need to add hitbox.width here. If that one is not solid either, that means we are not on the floor, so return false. But if any of these two are true, then we return true. We are on the floor. And that's all we need to do for this one. But that's not correct. We forgot one thing. We're not checking the bottom left corner and bottom right corner. We're checking the bottom left corner plus 1 pixel. And bottom right corner plus 1 pixel. The bottom left corner and bottom right corner doesn't matter. It's the plus 1 that actually does matter. So this is how we're going to check whether or not we are on the floor. And if it is not true, then we are in the air. Simple as that. And we can actually remove these brackets. We don't need them. And I think that is all we need to care about, right? Yeah, let's give it a try one more time. And we're stuck in air because we're only checking if we are in air, if we're moving. So that might be something we're gonna fix soon as well. But first, let's just move to the right. And I fall down. And if we're on here, yeah, it's looking pretty good. Not gonna lie, it's looking pretty good. And I can jump up here. Yeah, that looks all right. Perfect. Now let's fix the animation, and also the starting position should also be checked whether or not we are on the floor. So let's do that. And it's going to be very easy to fix the animation. All we need to do here is to check whether or not we are in the air. If we are in the air, then we're gonna have different sprites. And we're gonna do that by asking if we are in the air before checking if you're attacking. If you're attacking, then we're gonna have the attack animation, which is more important. So if in air, then we're gonna have two options. We're either going up or we're going down. And we actually had an animation for each, so why not use that? And our animation was actually in source, utils, constants, and here we have it. So we have a jump and we have a falling, and our player sprites have jump and fall. So we're gonna use that. So in air, in case we are in air, and if airspeed is less than 0, meaning we're going up, then we say player action is equal to jump. Else player action is equal to falling. I think those are the correct ones. Yes, they are. So now we should have animation for going up and animations for going down. Let's give it a quick look. Yeah, we had one for up and we had one for down. Yep, we do. Perfect. And the way we're gonna check whether or not we are in the air when we start is to add a check in here. Would be ideal to check whether or not we are. But remember, we are actually using level data, and level data is not set here. Level data is set somewhere else. Where? Here. So here we can actually add the if is not entity on floor is entity on floor. Then we add the hitbox, the level data, and if that returns false, in air equals true. Just like that. And now we should fall down as soon as we start the game. And we did. Perfect. And there was actually one more thing that I noticed, and if we remove drawing the hitbox, or rather comment it out, let's start it up and see what it is. So if you can see at the very bottom of our player's feet, they're not touching the floor. They are 1 pixel above the floor. And that is not to the fault of our collision detection. It's actually doing exactly what it's supposed to. It's actually the size of our hitbox. It's actually 1 pixel too big in height. So instead of 28, it's going to be 27 in height. So let's give that a try. And now it actually looks like he's standing on the floor and running on the floor. And hitboxes works perfectly still. So that's just something that we missed when we actually decided how big the hitbox should be. It would still work as fine, but the player would actually never look like he was standing on the floor. So that's why. Hallelujah! The episode is over and we got a lot of work done today. We changed our collision detection and added jumping and also gravity. It's starting to look like a real platformer game now, and that's really fun to see. I would like to thank you for watching, and don't forget to hit that like and subscribe button. You can also support me on Buy Me a Coffee if you would like to. That 1000 mark is closing in fast, and it is awesome. Thank you guys. I'm a bit unsure what the next episode should be about. We can actually go several different directions now, since we have completed most of the backbone of the game, for now at least. So I will post a poll in the Discord, so check the Discord for more info whenever that comes up. Until then, my friends, take care now and have a wonderful day. Bye.